and welcome to the next episode where we continue exploring three types of laminated chipboard from different manufacturers. Today we are testing their strength. All the equipment is prepared, but first I want to talk about some changes. Well, not exactly small ones. This strange testing method is actually what caused the long pause between episodes. I already had the carriage and the Mohs hardness peaks, but after studying it more carefully, I realized the carriage originally set the peak at a 45-degree angle, which was designed for the classic pencil hardness test. Most peaks are sharpened differently from pencils, and the correct angle should be 70 degrees. So I modified the carriage. I made these oak spacers at 25 degrees, which added to the original 45 degrees gives us 70 degrees. Perfect, the angle problem is solved. But for most peaks to work correctly, and I plan to test quartz countertops, tempered glass and ceramics in the future, the pressure applied to the surface must also be correct. The old carriage applied roughly 800 grams of pressure. After some modifications, I managed to achieve the correct angle and also added a level to the carriage, so I can quickly align it. I also added additional clamps, because with this weight one clamp was not enough. Now I can precisely control the angle. When you set it perfectly and then release the carriage, the tip of the peak slightly presses into the surface and shifts. Next, the correct pressure of the peak on the surface for proper Mohs testing should be 3175 grams. To reach this weight, I had to extend the wheelbase of the carriage so the weight shifted forward. Then I added a base weight, calibrated everything on scales and fine-tuned it. In the end, I needed this large steel ball with a 70mm diameter, and with these magnets I adjusted the weight precisely. On accurate scales I got 3172 grams, which is well within acceptable tolerance. For softer surfaces like laminated chipboard or enamel, I also want to see a clear difference between loads, so I can remove this section and run a lighter version of the test. In that case the pressure drops to about 1100 grams, almost 3 times less. That will help us use the difference more clearly. So I've inserted the first peak, number 9, and we start the test with the full load. The procedure is correct. I don't apply pressure with my hands, I only move the carriage using the wheels. Oops, I placed it too far, the second wheel wasn't touching. Let's go. I'll immediately remove the weight afterwards, so I don't have to constantly swap peaks back and forth. Then I make a second scratch right next to it with the lighter load. And we repeat this for all peaks. Now switching to number 8. Leveling it. That's important because if the carriage tilts even slightly, the weight distribution changes and the pressure becomes incorrect. Nine, 8 done. By the way, I forgot to mention, this panel is from ENG. Next we need number 7. Loaded. 1, 2, 3. Remove the weight. Move slightly. 1, 2, 3. Of course, everything scratches now for now. Now number 6. 1, 2, 3. Remove weight. Move. 1, 2, 3. Yes, there are differences. 9, 8, 7, 6. Let me label them. For this I created indexes. This is M9H, heavy load. This is M9L, light load. And so on for 8, 7, 6. Next is number 5. Done. We put loaded. Let's go. 1, 2, 3. Without the weight, it rolls much easier. Switching the peak orientation. Now number 4. We put loaded. Let's go. 1, 2, 3. Remove weight. Move. 1, 2, 3. Interesting, that one rolled very easily, like it didn't scratch. Perfect, we saw the difference. Pick number 4. Scratch it under full load, but not under light load. That's exactly the result I wanted. Now let's insert number 3. If you look at my previous preliminary test, you will see that peak 5 didn't scratch there. That's because the previous angle was wrong. At 45 degrees it tended to slide rather than dig into the surface. So, number 3. Loaded. Let's go. Remove weight. Move. Obviously, if 4 didn't scratch under light load, 3 won't either. Done. Let's also test the softest peak. Number 2. I didn't test it before. It's interesting. Peaks number 2. Full load. Wow. And here is the result. Angle is correct, pressure is correct, but the number 2 peak simply broke. It's made from some kind of polymer. So I won't replace it. The metal peaks are more durable anyway, since they can be sharpened again. So we'll limit our scale to level 3. No big deal. That was Arbor. Here are the results. I even put a Losev lamp so we can see the scratches better. Without it, the scratches are very hard to see. The results of testing here. On the left we have full load, 3175 grams. On the right, light load, 1100 grams. I can see the scratches very well. Turn on the lamp. Now you can see it better. Peak 9 scratches deeply. Peak 8 also. 7, 6, 5. Peak 5 begins to skip slightly because of the surface texture. 4 and 3. And this mark here is where the number 2 peak broke. Now you can clearly see the difference between full and light load. Peak 9 scratched under light load, 8, 2, 7 scratched, 6 scratched, 5 scratched. Peak 4 and 3 barely affect the surface. The idea was a success. I'm keeping this testing method. It was Eger. Now we move to SwissKrono and make same procedure. Now Kronospan. So let me give a full summary for the 3 panels and what results we got. We'll go in the order of testing. First we scratched Eger. So we have scratches, on the left we have the full load, on the right the partial load. Let's look. This was number 9. There is a deep scratch, on the lighter load there is also a scratch. Number 8. Number 7, heavy and light load scratched. Number 6, under full load is clearly visible. Under partial load it already starts to disappear. Here I rubbed it with my finger. Now number 5. Under full load there is a scratch, under partial load it looks like a very thin cut, like from a knife. On number 4, under full load there is a scratch, under partial load, well, it's basically not there anymore. On number 3, again under full load there is a scratch. Under partial load the rod just left a mark here. I wiped it off and now it's gone. So basically number 5 under partial load almost doesn't affect the surface anymore. 4 nothing, 3 nothing. And this here is where the number 2 rod broke, the one that was made from some kind of polymer. I won't be using it anymore. Next we look at SwissKrono. The logic is the same. The left column is full load, the right column is partial load. First of all, we immediately see that the scratches are much deeper. You can actually see the chipboard through them. Let's go. Full, partial, full, partial, full, partial, full, partial. And what's really surprised here, look at this. Even with number 4 under full load, it actually broke through the material deeper. You see this dark spot, that's the chipboard base underneath. For comparison, number 4 leaves a scratch, but number 3 doesn't. So that's an interesting comparison. Next we move to Kronospan. let's go. Number 9, full load, partial load, both scratch. Number 8, full load, partial load, both scratch. Number 7 yes, number 6 yes. Number 5, under partial load, also scratches. Number 4, under partial load, also scratch. Number 3, full load, scratches, partial load does not. So based on this test we can make some interesting conclusions. First of all, the results show that the manufacturers are very close to each other. Overall, the coating quality is quite comparable. Apparently they use similar materials and the level of standardization is already very high, but there are still differences. So let's go over it again. Third place goes to SwissKrono. Why? Because it only resisted the number 3 rod under partial load. Everything else scratched it. Also, the scratches under full load are very deep and root. And even with number 4 under full load, I can see the chipboard base underneath. So this one gets third place. Second place goes to Kronospan. Why? The key point is that it was not scratched only by number 3 under partial load. All heavier rods scratched it. But again, the scratches are not as severe as on SwissKrono, and I don't actually see the base material coming through. Only with number 9. So Kronospan takes second place. First place goes to Arbor. Why? Because it has a clear advantage. Rod number 4 under partial load couldn't not scratch it, which the other two samples couldn't achieve. That alone is already a strong argument for the first place. Secondly, it shows the least visible damage from scratches under full load. So Arbor takes first place. Now we move on to the second stage of testing. We are going to hit these panels with steel balls. What do we need to do? We need to secure the panel on a concrete base. By the way, this is another thing that significantly affected to delay in the releasing new episodes. Before I used to place the panel without clamping them, just laying them on plastic toolboxes. That created a spring effect, and what happening was this: balls with a diameter of about 25-30 mm, weighing 65-111 grams, were actually breaking through the panel. Not because they had enough force to penetrate the material, but because the spring effect allowed the panel to flex, and the point of impact concentrated the force. But when I used larger balls, like this one here, they sometimes didn't damage the surface at all, which is incorrect. Physics works differently than that. So I looked into how real laboratories test materials, and what they do is prepare a rigged base. So I built a metal frame, and inside it I poured a concrete slab. Now I place the material on top of it and clamp it around the edges. Only after that do I perform the impacts. Alright. Now I need my tube, which will control the drop height. I also need a marker to record the bulb diameter. And we begin. Without the Losev lamp, I wouldn't even see these impacts. It helps enormously. Look, for example, here is a 15 mm ball and a 20 mm ball. The ball makes a primacy impact, and then after bouncing it leaves additional marks. I'm not going to record those secondary marks, I only record the primary impact mark from the ball of a specific diameter. You know what's surprising? I put balls of different diameters and weights. In the previous test, the 20mm ball couldn't do anything. But in this test, the 10mm ball, just to give you an idea, the 20mm ball weighs almost 33 grams, while the 10mm ball weighs about 4 grams. And even the 10mm ball left marks. Alright, I also have micro balls in reserve which I didn't expect to use in this test. For example, here's one with a 7.5mm diameter. Do I have its weight recorded some here where? No, sure, I didn't write it down in this box. Let's see. Okay, that's good. That means I don't even need to unpack the 5mm ball. The 7.5mm ball left no damage, so I just write down on the panel 7.5 and cross it out to show that it did not leave a dent. Now we replace the panel and run the same test. Well then, I have now completed the drops with all the balls. A very important result I achieved is that the concrete base allows the test to proceed sequentially. In other words, the damage starts with the 10mm ball, and every ball larger and heavier than that reliably causes damage. That was something the previous version of the test was missing. Now, the results. What did not damage Arbor? 7.5mm. What did not damage Kronospan? 7.5mm. What did not damage SwissKrono? 10mm. What's interesting is that in the scratch test SwissKrono turned out to be the weakest, but in the steel ball impact tests it turned out to be slightly stronger. However, I see this as being within normal margin of error. After all, 7.5 and 10mm are extremely small balls and their difference is practically insignificant. Let's start with Arbor. I marked 7.5 as not causing damage. Let's go 10mm. Very teeny mark. Next 12mm. You can see slightly. 15, 20, 25, 30, 35, 40, 45, 50, 60, 70 and 90mm. My impression. There are dents. With the larger impacts, the laminate eventually cracks, of course. But I still don't see anything that looks really severe or exposes the chipboard base. Next. SwissKrono was next, I think. Let's check. 7.5, not damage. 10, no damage. Next. 12 millimeters. While it was lying there, I saw it. Here it is, a tiny mark. Next. 15 millimeters. Here is 20. Actually, I can't place the lamp too close because of overexposes the surface and hides the mark. Like this is easier to see. 15, 20, 25, 30, 35, 40, 45. Where is 50? Here. Then 60, 70, 90. Very similar damage compared to Egger. Now Kronospan. I also noted 7.5 did not cause damage. 10, here is the dent, 12, 15, 20, 25, 30, 35, 40, 45, 50, 60, 70, 90. Now, what conclusions can we draw from this test? First of all, we see a small but visible difference, thanks to the fact that very precise testing tools were used. We have calibrated Mohs peaks, we have the carriage, we have no manual pressure from my hands, we have steel balls dropped from the exact same height, and we have a rigid base fixing the material. So yes, there is a difference. But first, I highlight the difference using the Losev lamp, which you don't have in everyday life. Second, I show it through macro camera shots. Third, I intentionally use solid color materials because solid surfaces show damage most clearly. If I had added a panel like this one with wood grain, it would be almost impossible to see the scratches. Along the grain, across the grain, the visual texture hides damage. Even the impact dents would be hidden by the natural wood pattern. Next point. What we actually got are materials that are very comparable in quality. There are not dramatic differences like if we compared laminated chipboard with, for example, metal. There the difference would be catastrophic. Here, modern market competition and manufacturing standards lead to very similar products. Even though in the scratch test I signed first, second and third place, that's mostly the result of a proper testing method. It's interesting from a scientific point of view, but what happens in real life? In real life you will never feel this difference because it's extremely small. If you hit the surface with a metal object, all three will be damaged. If you touch them gently, none of them will be damaged. That's simply the reality. So choosing a material based strictly on the test ranking is not very meaningful, because in everyday use you won't feel this difference. The test results show that the quality levels is essentially comparable. Another point about the Losev lamp and macro shots. Right now I have a studio lighting. I'm not using the Losev lamp. I'm looking at all three panels and I cannot actually see the steel ball impact marks, because the material was not broken. Yes, there are dents. Yes, it's a solid color material. But when I look at it normally, the only thing I see are marker labels. I actually have to tilt the panel and search for the right lighting angle to see the damage. And that's very similar to real life. You don't walk around inspecting every surface in your home. Maybe a small dent appears somewhere. Most likely you never even notice it. I suspect that if you took a Losev lamp and walked through any apartment with furniture, shining it on every surface, you would find a huge number of scratches and dents. But you simply never noticed them before. So I hope this test was interesting, and I hope my conclusions will be useful to you. See you in the next episode.